Here I will tell few types of questions, like few points in mechanics and ways of solving. So let's first see the kinematics. So what kind of problems can we get in kinematics? For in two-dimensional motion we can have acceleration or relative motions, and in three in and let's say 2D or 3D motion we will get some questions related to rotation frames, and which sometimes we need to get into the rotating frame. Means we should start rotating, we should take a rotating frame so that this whole body looks static, and there would be some pseudo forces acting in that case, and the centripetal force would become zero in that case, because the centripetal force become balanced with the centrifugal force. So and nothing else. In some questions we may get the AX relation, and the question may be asking about time with respect when position is given, so XT relation. So to get this XT relation from this AX relation, we can simply use the equation A is equal to Vx dV by dx, and now integrating A with dx we can get Vx dV integration. And because A is relation of A with X is given, we can write it here and integrate. This will give us the equation of velocity with respect to time, with respect to position, and then we have to put V is equal to dx by dt and its equation here in terms of x, and then in solving it we will means dx by the expression of x for the velocity equals to dt. Now integrating it we will get the relation for time and position. So in this way we can get this position time relation. Okay, and what kind of questions in kinematics? We can have the question of type of projectile motion on any slope, upward the slope or downward the slope. In that case we can use the relation of the displacement along this length is this slope, and the change in height with respect to the displacement, relating these values, and we may see the motion of this projectile on this surface in this new axis. Let's say this is x dash and this is y dash, and we can solve along this, but we should be careful that along this direction there would be some mg cos theta component, while there would be some g sin theta here, and g cos theta component in this direction. The equation for time of flight the equation of time of flight for reaching the max point, let's say it is released with some velocity along this v by dash. Let's say the v by dash velocity component initially is this, and so to know up to how much height it will go, let's say this height is h from this slope, then that would be simply given by this. Just take this g cos theta in this case instead of g, and the equation becomes v y dash square by 2g, that would be equal to this height h, and the time of flight will be given by v y dash by the g into 2, that would be the total time of flight from going to top. This would be t f by 2, and then going bottom. But this won't be this shape won't be in this form. The projectile will look like this, it will go like this and fall like this, because in case of horizontal, when projectile is thrown, the shape of the projectile looks like this, symmetrical about this vertical line. So it won't look like this, but instead like this form. The calculation of r will not be easy, but after you have calculated the time of flight through this equation, then you can simply use the equation of motion and put the constant acceleration g sin theta in this direction and initial velocity vx dash in this direction, and solve the displacement in that tf time. This is how we can solve along the slope, and there are formulas for it, but the formulas are complicated, but we can memorize the value for the r max on the slope. Now there are other question of type, let's say a particle is thrown at any angle theta, and it is asked in the question, if it is thrown at v speed and at some l distance, what is the maximum to reach the maximum height at what theta is to be released. So in order to answer such questions, we have a concept called safety parabola, which says that the extreme positions, the safety parabola actually relates the extreme positions the particle can go at any given speed. So you can, so it means that, so what safety parabola actually is that this is origin 0 0, and you have a free speed and you have the freedom to release at any theta. Then if you release at small angle, it will go up to this distance. Then at 45 degree it will go up to maximum range, and then it goes becomes lesser, and similarly you can throw at other side. So the extreme positions, if you join the extreme positions, the shape will become a parabola, and this is the r max, this position is the root, and this minus of r max is the another root of this parabola, and this is the vertex, which is the maximum height, h is equal to v square by 2g. So we can write the equation of the parabola using these roots and this one point on this graph, and any point will which is thrown with a speed v will not come out of the safety parabola. The maximum it can go is up to the safety parabola, and there is equation of safety parabola. When a body is thrown with a v naught speed, then in that case the body will go up to g bracket, let's say its y coordinate is, it has to reach this y naught coordinate, x naught coordinate, then it will be g bracket y naught plus square root of y naught square plus x naught square, where y naught x naught are the positions where this particle is required to reach, and v naught is the minimum speed needed to reach this point x naught y naught. Okay, so one more thing is that to get this theta for reaching this extreme position, for means to hit any point on this safety parabola which is at x naught coordinate, which has any x naught coordinate, then it's tan theta. The angle of throw can be given as, what was the angle of throw, I'm forgetting it. Okay, so let's check it as I forgot. So it is v naught square by gx naught. So tan theta naught is given by v naught square by gx naught. So that's, if you are given the velocity means speed and the x coordinate, so to hit the parabola at that point, this is the angle at which you should throw it. And now moving ahead, one more thing in projectile motion, under the gravity is in one direction vertically downward, and because this is the acceleration vertically downward, and because there is no other acceleration horizontal, so the horizontal component of the velocity will always remain constant, which is one more point. Okay, so in some cases we may need to differentiate a rotating vector, and I will write for any vector, let's say a, its unit vector, let's say a cap, when differentiated with time it gives value omega cross a cap. If you want to differentiate the total a non-unit vector, then you can just add other term of, okay, you can differentiate it, that won't be a big task. Okay, so that's kinematics, and now moving to the NLM, or if we need anything else. Okay, now, okay, in relative motion questions there is nothing big deal. In some cases we may be needed to write the relative motion, and it is easy to write any vector a1 with respect to 2 when you are, let's say, you know that what is a1 with respect to 3, then you just have to know the value of a3 with respect to 2. You can add them together and you will get the a1 2 vector like a chain 1 to 3 and 3 to 1. So overall this will become 1 to 2 when you are linking them in this manner. Just add them all. So that's it, and nothing else. When we take any body's frame, let's say this body is moving with some v velocity, and in its frame, when I go into its frame, let's say another body is moving with some velocity v1 in the same direction. Let's say it has velocity v vector, it has v1 vector. Now doesn't matter in which direction. Now if I go from rest frame to this moving v velocity frame, then all of the velocities will become v1 minus this velocity will appear. This is the apparent speed, which is v1 minus this v vector. Now let's say I was sitting on this frame which is moving with some v velocity. On this frame, when I observed a mass, a particle which was moving with some v1 velocity vector. Now if I go to the rest frame, then this particle will be having v1 plus v vector velocity. Means if you leave this frame and go to the rest frame, this velocity is added, but if you go from rest to this frame, this velocity is subtracted. Same goes for any other vector, whether it is acceleration or position vector. Now the NLM, or maybe, okay, in some cases we may need, in some questions like a ball is thrown from one building like this, there is some distance given, means all necessary information is given, and two balls are thrown like this, and in order to hit this, we may be asked for we may be asked for some conditions. So first of all, in such type of cases, it is easy if you go into the if you go into a suitable frame in which this question solving becomes easy. So if I go into this frame, accelerating g frame, then in that case, so first of all, let's say this mass is released at, let's say, t is equal to 1 second with some v1 speed. So t is equal to 0 with v1 speed, and then it is released at t is equal to t with some v2 speed, let's say horizontally. Both are released horizontally. So at first I need to wait till the time t is equal to t, when it would have fallen up to some distance and it would have got some v1 dash velocity, and at this time t is equal to t, I can go into the accelerating frame g, and in that frame neither this and neither this particle would be accelerating, because in that frame the g will get cancelled, because this is also accelerating with g and this is also having acceleration g, but when I go into the frame of g, this will be subtracted and cancelled out. So I just have to solve with these velocities, and to make them collide, I need to make sure that they reach up to the same distance. Let's say it has to go this L distance and there is some gap t, so this particle should go down by d L distance. In that accelerating frame, I am saying that if in that accelerating frame this particle travels L distance, so this particle should travel d comma L distance in this direction. If they are doing, means it is clear that this particle should not be released horizontal, because if it is released horizontal, this gap won't be removed. So it means this should be released in some downward direction so that it can approach this, because it has to travel some larger distance, and there would be a time constant that they have to collide, then they have to meet together, and that time would be also same for them to travel this distance. Means the time taken for them to approach each other horizontally would be same as the time taken to approach in this vertical manner. And one more thing, that the collision may not happen if the expected collision is under the ground. Means it is possible that the collision is supposed to occur here, theoretically it is supposed to occur here, but the ground is at this level, so collision cannot occur in this case. So we need to make sure that the time of flight is smaller or equal to the time of collision required. Now one more thing here, initially when it was released and it was not released, I didn't take the accelerating frame because this was accelerating with g but this was not accelerating. So if I take this frame g, take the frame of g, this will get cancelled, but this will get some g acceleration, so it is useless to make one easier and other complicated. So that would be useless to take any frame. Now okay, so in kinematics there would be some questions of constraint. Constraints are of type like the any 2 points which cannot be separated, means the length between these 2 points if cannot be changed, then it means dl by dt is 0, means the velocity of b and velocity of A can be anywhere. These two particles can be having velocity anywhere, but the component of their velocities along this line, means let's call the component along the line L to be V parallel, VA parallel and VB parallel. So the let's take their velocities along the same direction, and then they should be equal, because if they are not equal, then either this would be stretching or compressing, which is not possible because the length is constant. So they both, these values of velocities should be equal to each other, these parallel velocities. So this is how we solve the constant equation, or we can solve by simply writing the relation of displacement of individual particles. So that is another method, and we may differentiate it later with time, like dy dt, and we will get the velocities equation. And other than that, there is one more method for especially string or massless bodies, for massless bodies that connect some masses. In that cases, because the body is massless, the string is massless, there would be no energy gained by the string. So the work done on the string is zero, and action reaction law suggests that the work done by the string is zero. It means the work, since the work done on a string is zero, the work done by the string will be also zero. So in any manner, we can calculate the total work done by either string or by either all the objects on the string, and the total sum would be equal to zero. And one more thing is that the string must be continuous. We cannot take one string, this string, and let's say this is another string, but it is not part of this system, then you cannot treat them as single string. Only those string which are kind of, let's say if I, what can I say? If I join this, let's say this string is split into two parts, and then there are two masses here, then no problem, the mass connected here, then we will take the work done by the string here, tension here, and here there is no mass here, we won't calculate any, but this whole string would be considered as a part of the same string. And then work here, and total sum of these works will be equal to zero, and that work would be having either plus or minus sign and somehow cancelling out each other. So one example for this is that, let's say a block is moving in this direction with some v velocity, and this is pulled with some u velocity, and this is, let's say, theta angle. So when we pull this with a constant speed, let's say u, since this thread is moving with u velocity, the other points will be moving, each point on the thread here, this is moving, let's take a point here, this should also be moving with u speed along the thread, means this u speed is along the thread, so each point on the thread should be having a u speed along this thread. So I took this point which is moving along this thread in this direction, let's say, and let's say this point is moving with some v speed in this direction. And to solve the constraint using this constraint method, because this string cannot expand, we can get the value of this v, component of v along this v cos theta should be equal to this velocity along this string u. So it gives that u is equal to v is equal to u by cos theta. And another method is taking all the possible positions where the string can work. So there is one contact point here, other external one here, and there would be some person here also. So it is not shown here, but there would be someone pulling it. So we will take some tension here, applying in this direction, while the body is displacing in this direction. So let's say the person displaces by dx displacement in this direction. So tdx minus tdx is the work done here, while here notice, while here this tension is acting in this direction, but there is no displacement of any object here, so we can ignore it. Now this object is moving with some displacement in this direction, let's say it is dy displacement in this direction, and tension tx in this direction. So we get plus t dy, and the tension is component with this dy is cos theta, and that summation should be equal to 0. That's the total work done by the tension forces everywhere in this system. Here at this point, this body is not moving, it is not making any displacement, so we can say that no work is done here. So we get here t dx is equal to t dy cos theta, and simply t cancels out, and differentiating with time we get u is equal to v cos theta. Again same relation comes, v is equal to u by cos theta, and this can be directly given as, simply we can replace this dx with the velocities of these points. And here I was calculating the work done by the tension. I can do the different way, which is, if someone is pulling it with t tension, then it is also pulling back with this string with t tension. So we can say that this block is doing some work on the string, which is equal to t in this direction, its component in this direction is cos theta, and if it is moving with some dy displacement in this direction, total work done by this block on this string is minus t cos theta dy. And then this body has, there would be some, at this point there would be some tension t applied in this direction and some tension in this direction by this rope on this bolt. So in reverse, this should apply some t tension in this direction and some in this direction. Okay, and because this body which is supposed to do work, it is not making any displacement. When the force, the point at which force is applied, that is not moving, means this, the object which has to do work is not moving up. The point of application of the force is not moving, the work is zero. Here this is moving with this, tension is applying in this direction t, so this object or the body should also apply reaction force t on this string, and if it displaces by dx, the work done is t dx is equal to total work done will be 0. So again we get same relation, either by solving work by the string or work on the string, both will give the same results. And we can instead remove this dy, and we can write here v, and remove it and write u, that is t dx summation is equal to 0, and dividing by dt we get this summation of t with velocities, the bodies contact points, that would be equal to 0. These are two direct relations, but we cannot directly get the we cannot say that t into a is equal to 0, because then we have to differentiate it. Here we did not differentiate, we just divided by the time taken, which would be a non-zero value, and it doesn't matter if you divide both sides by dt, and this would become simply velocity. But here, to get acceleration from the velocity, I need to differentiate it, and differentiation means there would be a cos theta also. If the theta is changing, cos theta would be changing, and we need to differentiate it also. So it won't be this equation anymore, there would be some terms of cos theta again. So we can write this equation equal to 0 only when each theta, means this cos theta in this equation, each cos theta in this equation does not change, each of them remain constant. Then in that case we can say this, because then we can treat cos theta as constant. Okay, so that's all types of questions. And in some cases of approach, time taken to approach, and some approach related questions, we may need to write the equation of dl by dt, means velocity of separation or velocity of, or the velocity of approach. We need to write the equation of that, and it will help, because we may know that after catching the distance becomes 0, and initially the distance would be given some L, so it is easier to calculate. For example, in this case of triangle where a b c are persons, where a moves toward b with v speed, b moves towards c with v speed, and this moves towards c with v speed, and let's say this is an equilateral triangle. Then in that case, there is a symmetry, and each of them would be, let's say this whole triangle is this body, a point moves here, then c moves here, this triangle will start rotating, and it will become smaller in size with time. So if we go into that rotating frame, this triangle will look same in size, means not rotating, but its size will start decreasing with time. It will feel like that triangle is decreasing in size, and we just need to know how much time it would take for this a particle to reach this point. And if I write the velocity, let's say if I take this AB points, A is here moving with some V speed here, and B is moving with some V speed here at this 60-degree angle. So when I write the velocity of separation equation, I will get V velocity in this direction, component of it V cos 60 degree, which is V by 2 in this direction. So there would be 3V by 2 velocity of separation, or here it would be velocity of approach 3V by 2, that would be equal to dl minus dl by dt. And now solving it, we will get the time taken for the distance. Let's take dt here, and the time taken for it to go from this, let's say this side was L, from L to the 0, there was a minus here. Okay, so okay, let's see some questions, only few questions. So there is one question here from J-Mains 101. Let's solve this. So there is a particle moving in a circle whose normal and tangential component of its acceleration are equal. We know that the tangential acceleration is dv by dt, where v is, let's say, the mode of, let's say, the speed, and normal acceleration is v square by r, and it is said that both of them are equal. Then the time taken for to complete the first. So it means that with time, because of the tangential acceleration, the speed will increase, and as the speed increases, the normal acceleration, that is v square by r, will also increase, and as the normal acceleration increases, the tangential acceleration also increases, and the rate at which the speed increases also increases. So the speed starts increasing at a higher rate with time. So now we have to solve it. So simply we are given that the radius is 50 centimeter, or we can say 1 by 2 meter, and at t is equal to 0, the speed was given 4 meter per second. So it is given that dv by dt, that is the tangential acceleration that causes the change in speed, is equal to the normal acceleration that changes the direction, v square by r, where r is 1 by 2. Now we have to just, it is asked what is the time taken to complete the first revolution. So from this velocity time equation, we cannot directly say that what is the time taken to complete the first revolution, but if I can derive an equation for position with respect to time, then I can tell the time taken for it. But no problem, first we will write the relation of vt, then we will replace v with dx by dt, and then solve. So we get dv by 2v square is equal to dt, which gives, this integration gives from, let's say, initial is 4 to the v velocity from 0 to the t time. We get integration would be minus 1 by v. So 1 by 4 minus 1 by v is equal to this, or let's take this 2 here. Now this is the equation of velocity. Simplify it, we get, we want to write this v as dx by dt form, so let's try to take it to the numerator and make it single variable here. Means I don't want to increase the number of v, so I will simply take 1 by 4 minus 2t equals to 1 by v, and then I will take the reciprocal of it, so it will give v is equal to 1 upon reciprocal of this, which is, let's say this is 4 to the 8 divided by 4. So now taking the reciprocal, which is 4 by 1 minus 8t. Now I can replace this v with dx by dt. Now integrating this, so taking dt here, now integrating with dt, we will get, I want to complete first revolution. So to complete first revolution, I need to go from the 0 to the 2 pi r, which is 1 by 2, cancels 2. So I want to go from 0 to pi, and this time goes from 0 to t. I want to find the time taken. So it will give, this becomes ln 1 minus 8 t divided by the initial 1 minus 8 is 0, which is 1, is equal to pi. Now this value becomes pi by 4, and taking it to the power 1 minus 8t. Now 1 minus 8 to the power pi by 4 is equal to 8t. Now taking 8 here, the time is equal to 1 minus e to the power pi by 4 by 8. This there is some issue here because the result is not correct. Okay, I got the problem. Found the problem. That was because I didn't notice this minus 8. So because of this minus 8, I will get a minus. I will get minus 8 at the bottom, at denominator also, I guess. So it means the integration would look like 4 by minus 8 ln of 1 minus 80. Now it is correct, is equal to pi. So this becomes minus 2 at denominator, so it becomes equal to minus 2 pi, and now it becomes 1 minus 80 is equal to e to the power minus 2 pi, and now we can write e to the power minus 2 pi is equal to 80. So we can take it here. So now it matches with the result of the question where this value is equal to alpha. So answer of alpha is 8. That's it. Okay, this is another question, 139. Circle table is rotating with a groove as shown here along the radial direction. Radial direction means it is passing through the center. Steel ball is gently placed at distance 1 meter, because if it was placed exactly at the center, it would be at stable equilibrium. Okay, and all the surfaces are smooth, and I have to find out the time it will leave the table, means the time at which it will reach the corner at the edge. Nothing simple. Kinematics. So the question said this such that there is a circular table which is rotating with some omega angular velocity, and there is a groove about it in this manner, and from the center up to 1 meter distance there is a body placed which can slide along this, and I have to, this total radius is, let's say, 3 meter, and I have to find out the time at which it will reach the end. So okay, now to solve this question, like I said, sometimes it is better to go into the accelerating frame. So if I, let's say, set my axis as this and y as this, so as this body keeps rotating, my axis is also rotating, and in that rotating frame, let's say this object is at any r distance, then the centripetal force, centrifugal, let's say this has mass m, then centrifugal, there would be some pseudo acceleration in this accelerating frame. I will have some pseudo acceleration on this body, that will be omega square r in the outward direction. Either I can directly solve using this, or I can say that there would be some pseudo force omega square rm in this outward direction, and dividing by the mass m cancels, and this is the acceleration outward in this rotating frame. So this whole setup now looks static in this rotating frame of omega angular velocity, and there may be some forces from the sides of this group, and we don't need this because we have to calculate the motion along this x, not y. So we know that this acceleration along this x is a is equal to omega square r, and that is a constant value, sorry, that is variable with r, and I have to find the velocity of the, sorry, I have to find the velocity of the ball when I have to find the radial velocity only. So okay, this is omega square r, that is expression, is equal to vx dv by dx, and fortunately in this case this v velocity I am taking is itself the dvx, so I can say that both are dvx. The whole velocity is along the x, so there is no problem as writing vx or v, so I can simply integrate it as dv by dx is equal to, or this dx is actually dr, the distance along this is r. So omega square r, now taking dr here at this side, now integrating both of them from 1 meter to 3 meter, velocity will be from 0 to the v, so it gives v square by 2 minus 0 square by 2 is equal to, this becomes omega square is constant, r integration gives r square by 2, so it becomes 3 square minus 1 square by 2, so it gives velocity square is equal to 2 cancels 2, 3 square which is 9 minus 1 is 8 omega square, so velocity becomes omega 2 root 2, and the question says that the velocity is equal to x into root 2 omega. So the value of velocity is x is equal to 2. That is the answer. And in this case, this is the velocity along this x, while this body, because this body is rotating and I am taking this rotating frame, so when I go to the ground frame, I will see that this object at this point of time will be having some rotation, so it will be having some omega into 3, that is omega into 3 velocity in this tangential direction, and this radial velocity would be this omega 2 root. So the total velocity would be 3 omega whole square plus omega square at root. This is the total velocity of this body at this point if the omega is not changing according to the question. Okay, kinematics is done. Now let's do mechanics, sorry, NLM. So in NLM, the types of question we will get are of like, we may get some friction related questions. So when we have to solve friction related questions, we first try to make all the possible cases. For example, let's say there are 4 blocks here, 1 2 3, some coefficients of frictions between them, this is let's say frictionless, and let's say one of them is pulled or 2 of them is pulled. So to solve the question, we make different cases. One case can be all moving together, other could be slipping occurs here and rest of them move together, or maybe slipping occurs here and these two move together, or slipping occurs here, these three move together. And there could be more cases we can make, that slipping occurs here and here and these two are moving together. Means we have to just make all the cases, and there would be some cases which are not possible. We will, for example, if the friction, means we will get to know about them by the difference of the frictions, means the maximum friction limit, we will get to know about the values. We will get an idea which will slip first and which will slip later according to their friction values. Okay, so one more thing is that friction acts before the tension force or any other force applied if it was not initially applied. Means let's say there is a block here and it is connected to a wall, let's say with a string. Let's say that initially tension is 0 and it is placed on a surface, but now I start pulling it, then it doesn't mean, let's say it is not moving. Of course it will not move because the string is inextensible also. So let's say I am pulling it with some F force, so T may remain 0 because there would be some friction acting here. First the friction will act, and then if this force overcomes this F force, then T will act, and F minus F would be equal to T. So there are questions on this, and one example is, okay, where is example? Okay, I don't see any example. Okay, one more formula. So based on this, there are questions like any wedge like this, and on this there would be two masses connected to some, let's say, string, connected with some string over a pulley, and there would be some coefficient of friction here, some angle here, masses, and it would be asked what is the tension here so that it does not slip, and what would be the acceleration of these bodies, kind of these questions. So we just need to keep in mind that first we will start from the rest state and see which has the more tendency to go downward. Will this tend to go down more or this one? So first we will just ignore the friction, and after knowing that this has more tendency to go downward, then we will see that, let's say it has a larger component of force in this direction, then we will then look for the friction force applied, and all of the friction force will try to cancel it so that it doesn't move. And let's say there is some force still remaining, then in that case that force will pass through this tension. There would be some tension that would be balancing that extra force, and this tension will pull it, and some friction, okay, some friction will act depending on if because there is some force by the gravity, there is some component of the force of the gravity along this direction also. So the tension should also balance this. Let's say the tension, this force left here is very smaller than this gravitational force, so it means that this gravitational force will try to pull this mass downward. So of course there will be some tension force because of this mass tending to slip, but this this mass this mass this mass will have some T-tension here, and because this mass is tending to go down because of this large force, there would be some friction in the upward direction, and it would be at rest. It won't move, but this may try to this was tending to slip, but it is now balanced by this tension force. Or let's say this tension force is large enough to overcome this force of this gravity downward along this slope. Then in that case this will tend to move in this direction, and the friction will now start acting in this direction, downward direction. So this is how we will analyze these questions. And okay, so I guess there is one more question that is related to kinematics more than NLM. So let's see this. So this question is two masses 2 kg 8 kg are there connected with this pulleys, and we have to calculate the time taken after the system is released. We have to calculate the time taken by the box of mass 8 kg to strike the ground starting from the rest. The height difference is 20 centimeter. So we have a pulley here and another pulley here, and this pulley is connected to a mass 8 kg, and there is 2 kg mass at the ground. Now initially this 2 kg mass is on the ground, and this 8 kg mass is hanging on the air, which means there would be some 4 Newton tension here, which is balancing this, sorry, 40 Newton and 40 Newton tension here, which is balancing this 8 kg mass. And there is this 40 Newton force here and 20 Newton force here initially. Okay, so initially when this was the case, this whole setup was in this state where this mass was also tending to go upward. Okay, everything was tight, and now we released it. Now after we released it, the tension will be something different. This, let's say this goes down with some a acceleration, then if this is going downward with some a acceleration, then this will go down with some 2a acceleration, and this will go upward with same 2a acceleration. And now we will write the equation of the free body diagrams, whatever. So this 8 kg is having 80 Newton force downward and 2t tensions upward, that is equal to this 8 kg mass into acceleration, while this 2 kg block has 2 acceleration upward, 2a into 2, which is 4, and where only one force, where this 20 Newton by the gravity is downward and some tension is upward, so 10 minus 20. So these are the two equations. Keep okay. So now simply taking the sum, I get 12a is equal to, oh sorry, I have to just find the acceleration, so I can multiply it by 2, it becomes 40, it becomes 30 right now. Okay, right now this cancels out and we get 40 is equal to 16a. So it gives a is equal to 40 by 16, and it is asking me what is the time taken for the 8 kg to go down to the bottom when the distance is 20. So time taken, so we have the equation starting from 0, starting from the 0 time, let's say it takes time t, and it is having a constant acceleration. So let's say the final velocity v square is equal to, final velocity v square is equal to 2 times of as, which is 40 by 16, and displacement is also downward by 20 centimeter, which is 20 by 100, which is 2 by 10, which is 1 by 5. So we can write it as 2 8 16, and so it becomes 1. So the velocity becomes 1, final velocity becomes 1, and under the constant acceleration the average velocity becomes v final plus v initial divided by 2, which is 1 by 2. So the average velocity is 1 by 2, and the distance is 20 by 100, that is meter, divided by the speed, that would be the time, which is 4 by 10, which is equal to 0.4 second, which is the answer. Okay, we could have solved it by using the quadratic equation, but sometimes solving with quadratic is lengthy and some other methods are fast. So there is this question from the J mains. It's 93 questions about the friction question. So let's solve it. So it says that doubly inclined plane to masses m and m are placed. Blocks are connected by large string or ideal pulley. Coefficient of friction between the surface of the plane block is 0.25. Okay, it is for both 0.25. And the value of m for which the mass m kg will move down. So it is asking for the value of m for which the mass m will move down with this acceleration 2 meter per second square. And okay, fine. So the question says that question is already telling me that it is a very simple case of question, because I already know in which sense the body is moving. So body should be moving in this direction. So the friction would be acting in this manner and in this manner, and it is accelerating with some 2 meter per second square. There would be some tension T and T. So this the gravitational component mg sin theta, which is 3 by 4 into this mass m into g in this direction, while this has some force mg into 4 by, sorry, this is 3 by 5. Okay, so this is the force in this direction and this is the force in this direction, and t so t minus 3, sorry, this friction should be also subtracted, which is equal to cos theta, which is 4 by 5 mg times mu, which is 1 by 4. So it cancels out. We get mg by 5 frictional force here and downward with this gravity, and here we get some frictional force upward opposing the motion, which is capital M, which is given mg cos of 53 degree, which is 3 by 5 mg cos into mu, which is 1 by 4. Now solving, this total force is downward 4 mg by 5. T minus 4 mg by 5 should be equal to this acceleration is 2 into mass m, and for this body it is, the mass is already given 10 kg, so I'm just putting the value, minus tension is also subtracted and friction is also subtracted, m into 3g by 5 into 4, which is equal to again 2 into m. Now this m is equal to 10, so I have to calculate. Okay, what I have to calculate is simply this mass m. So just add these two equations, t cancels out, I don't need t, and I'll get 2m plus 4m g and divided by 5 on the other side with this 2m, which is 20, and this becomes 4 by 5 into 100 minus this becomes 300 divided by 5 into 4. So it is 20 into, so this becomes 20 into 4, which is 80, minus this is 20 into 5, 4 20 cancels, it is 15, and minus 20 is equal to m bracket 2 plus 40 by 5, and this becomes 60 minus 10 70, 60 minus 50 minus 5 45 is equal to m bracket 5 at the 40, this becomes 10. So we get 4.5 equal to the mass of 4.5 kg, which is the B option in the question, 4.5 kg.